Okay, so let's try to answer this question. How much force is needed to add to make the force acting on the object in order to balance it? So this is the object's drawing. And this is the object, and on right side it's 8 Newton, and on left side it's 5 Newton. So our main goal is to balance it. So how are we going to balance the force acting on an object? So we need to have a net force that is equal to 0. So if we have 8 Newton already on the right side, how many, and left side is 5 Newton, how many Newton we need to add in order to equal the 8 Newton on the right side? It's 3 Newton. So we need 3 Newton. However, the question here is in what direction as well. So we already know that it's 3 Newton. Is it 3 Newton downward? No. Because if it is 3 Newton downward, it will not cancel, or uh, it will not balance the force acting on an object. How about letter B? 3 Newton in same direction with 8 Newton, meaning to say we already have 8 Newton here plus 3 Newton. So we have 11 Newton on right side and 5 Newton on the left side. And it is not balanced as well. How about letter C? 3 Newton opposite to the direction of 8 Newton. So meaning to say we oppose the direction of 8 Newton. It's the same here. It's the direction 3 Newton. Now, we have 8 Newton on left side. We have 8 Newton on the right side. So we have here the net force is equal to 8 Newton on the right side. And then we have 5 Newton and 3 Newton on the left side, which is equal to 8 Newton. And since it's on the left side, so we have 8 Newton, negative 8 Newton. So now 8 Newton minus 8 Newton is 0. Therefore, the net force is already balanced if we answer letter C. So the answer here is letter C. We need 3 Newton opposite to the direction of 8 Newton in order to have a balanced force acting on an object. Okay. So the answer here is letter C. Okay, let's try this. Let's deal more with unmatching type. Okay, we're going to match here what is the resulting force and what is the direction. So let's begin with number 1 or letter A. So as you can see here, we have, let's solve for the net force. Okay, the net force is base here, 8 Newton to the right, and we have the next one, we have 2 Newton to the left, so it's negative. So let's compute for the net force. 8 Newton minus 2 Newton, the answer is 6 Newton. So that is the net force. Now, it's positive 6 Newton. So therefore, the direction of the net force is to the right. And the magnitude is 6 Newton. So what is now the answer? Okay, this is the answer. 6 Newton is somewhere here. Yeah, this one. Okay. Next, let's answer letter B. Kindly compute for the net force. So we have here, let's compute net force is equal to 10 Newton to the right, so it's positive, plus 2 Newton to the right as well, so it's positive. So 10 Newton plus 2 Newton is 12 Newton. So we have positive, so we assume that the direction is as well going to the right, and its magnitude is 12. So the answer here is 12 Newton to the right. So the net force is, okay, the answer here is this. Okay, okay, next. Letter C. Let's try to answer letter C. Okay. So here, let's calculate for the net force. So the net force of letter C is 8 Newton to the right minus 8 Newton to the left. So if we have here 8 Newton minus 8 Newton, the answer is 0 Newton. So now, if we have 0 Newton, meaning to say, there is no net force acting on the object because the net force or the force acting on an object is balanced. So there's no direction as well. So the answer here, 0 Newton, is this one. This one. Okay. Next, let's try the letter D, the last item. Let's compute for the net force. F net is equal to 5 Newton, positive because it's to the right, plus 3 Newton, positive as well because it's to the right, minus 10 Newton. Why it's negative? Because 10 Newton is to the left. And in our convention, if it is going to the left, it's negative. So we have here 5 Newton plus 3 Newton, 8 Newton, minus 10 Newton. So we have here 8 Newton minus negative 10 Newton, minus 10 Newton rather, we have here negative 2 Newton. Now, this is the net force. Base here, it's negative. So meaning to say the net force is going to the left. So the magnitude is 2 Newton and it's going to the left. So the answer here is this. Okay, this is the answer. So that is how you compute for the direction of the net force and how you compute for the magnitude of the net force. So always use the negative sign to represent the direction and the value as the magnitude of the net force. So how about the acceleration? Remember this, acceleration is always pointing towards the direction of the net force. So here in the first one, there's no acceleration. So it only means that since there's no net force, it only means that there's no acceleration as well. So because the force acting here is balanced. On the other hand, here, since the net force is going to the left, the acceleration is going to the left as well. On the other hand, let's have this. Here, the net force is going to the right, so therefore the acceleration is going to the right as well. And lastly, we have here going to the right as well, so therefore the acceleration is going to the right as well. So that is how we find the direction of the net force and how it is being related to the direction of acceleration. Okay, now let's try to identify whether the force acting on an object is balanced or unbalanced by computing its net force. So here, how are we going to compute for the net force? It's very simple. Let's just simply add all the summation, all the force acting on an object. And let us not forget to use the direction as well. So let's calculate for the net force. Base here, the force acting on an object is 8 Newton to the right, so it's positive, and 8 Newton to the left, so it's negative. So we have here 8 Newton minus 8 Newton, we have 0 Newton. Now, in order to determine whether balanced or unbalanced force acting on an object, if it is 0 Newton, meaning to say there's no net force acting on an object, the answer here is always balanced. Again, if the net force is 0, the force acting on an object is balanced. So the answer here is it's balanced. Okay, it's balanced force acting on an object. Now, let's try another one. How about this? Balanced or unbalanced force? So let's try to solve for the net force. So we have here net force is equal to, okay, we have here 8 Newton to the right, so it's positive. We have here 2 Newton to the left, so we have negative 2 Newton. So we have here 8 Newton minus 2 Newton is 6 Newton. So we have a value of net force. So it is not 0. And if we have value of net force, then it's an unbalanced force acting on an object. So the answer here is unbalanced force. So that is how we determine whether the object object's force or the force acting on an object is balanced or unbalanced.